it turns out that there's another useful product with vectors. And let's start with a motivating example. So let's say that we have this vector, and then we have this vector. Are they pointing in the same direction? And then we have this vector. How do all of these vectors compare? Well, so let's look at the blue one and the green one real fast. Let's write down what green is. Green is 3, 1, and the blue is the vector 2, 4. So if we take the dot product of this, what do? Well, we take their elements and we multiply them together element-wise. So what is 3 times 2? That would be 6. And what is 1 times 4? That would be 4. And we add them up to wind up with the number 10. So what the heck does this 10 mean? Well, this 10 is a measure of how much these two vectors are pointing in the same direction. If two vectors happen to be pointing perfectly perpendicular to each other, the dot product of the blue vector dotted with the red vector will equal 0. So if they're pointing perfectly perpendicular to each other, so if they are normal vectors of each other, the dot product is 0. And if they happen to be pointing in approximately opposite directions, so say this vector, we have the blue vector dotted with orange vector, and that should give us a number that is less than 0.